Hello, in this video we want to talk about the principle of free fall. What is free fall? Alright, so free fall is an application of motion in one dimension. Remember in previous videos we talked about motion in one dimension where we use about 6 different quantities to describe them, namely position, distance, displacement, velocity, speed, and acceleration. But we want to apply all these concepts to our day-to-day activity. So one of them is using free fall. But free fall is restricted to one dimension only. When we want to talk about 2 dimensions, then we'll talk about things like projectile or circular motion. So where exactly is free fall? So when we have a motion strictly under the influence of gravity, then we say the object is falling freely. Assume you have an object like a ball at a distance of x from the ground. So let's assume that this straight will be the ground surface. Yeah, this is my ground. Now the ball was released instantly from this position, coming downward. Was released coming downward. Now, in our reality, of course, we're tempted to say there are 2 forces acting on this ball: the force of gravity, which is pointing downward rather. So that looks like this: force of gravity, F of G, and then the air resistance or air drag, which is pointing upward. But for free fall, we want to neglect air resistance. We want to assume that the only force acting on this ball is the force of gravity. Now, if that happens, then we say this ball is falling freely and it is undergoing free fall. We have 2 types of free fall. We have symmetrical free fall and non-symmetrical free fall. What does the symmetrical free fall look like? So let's say, for instance, I were to be throwing the ball up instead of the ball falling down now, I'm throwing the ball up. Let's say my ball initially is at this junction, and then I want to throw it up in a way that I'm not throwing at an angle now. I'm throwing vertically, that is in a straight line in the y direction. And once I throw this ball up, after transferring energy from my hand or from wherever vessel I'm using to propel my ball upward, I notice that my ball will move in this direction, move like this, till it gets to its maximum point, let's say around this junction. So at this junction, what happens to my ball? You see that it will fall back down. Normally, if gravity doesn't have any effect on this ball will keep on going for eternity in space, just like Newton's first law. An object at rest wants to remain at rest, or an object in a constant motion wants to remain in its constant state unless an external force is acted upon it. So because this ball is feeling the effect of gravity, then it stops here and then starts falling down. So let's assume that it's falling down in this direction, so it comes down to the ground. Now, why we say this is symmetrical, of course, me drawing this second line is just to illustrate how the ball comes down along the same path on the straight line. Of course, there won't be a shift here. So this shift that I've drawn here is just to illustrate what is actually happening. So once this ball comes down, so we're now saying for it to be symmetrical, in as much as it is starting at the same level and ending at the same level. For instance, my ball starting at the ground, then finally it is ending at the ground. So the time, so if I were to call this point 1, if I were to call this point 2, and then if I were to call this point 3, so the time it will take my ball to move from point 1 to point 2 will be the same time. Time from 1 to 2 will be the same time to take it to move from point 2 to point 3. So we're basically saying, let's say you have a gun, and then you want to point the gun on your head and shoot. It will have the same effect as you putting the gun on your head, shooting upward, let the bullets go up, and then dropping down on your head. That's the same effect. So perhaps maybe what's it called? Perhaps the gun is too far, maybe it's something like a stone, but then uh, trying to throw that stone vertically upward along that same straight line might prove difficult. So I hope you can get the concept of a symmetrical free fall. It's all about the timing. The time it takes to move from the ground level to its highest position will be the same time it will take for you to move from your highest position back to the ground level. Then for non-symmetrical free fall, basically maybe you're starting at an height, maybe you're on a tower, and then you have a ball like this, you throw it upward, and then when it goes up, it lands way below or way above. Or this time around, you're throwing something downward. You're not throwing from the, it's not starting or it's not finishing at its starting level. So we say it is non-symmetrical. So how do we solve for this? Now we already said at point 1, point 2, point 3. Now at point 2, something interesting is actually happening. At point 2, my height is maximum. Height is maximum. So if my height is maximum, it means that my velocity at that point must be equal to 0. So height is maximum, velocity is equal to 0. At point 3, my height is minimum. My height is minimum, and velocity is maximum. Velocity is maximum at this point. So knowing this concept will help us in our analysis of solving for free fall. Now, since only one force is acting on my object, when an object is falling down or when an object is thrown up vertically, since only one force is acting on it, then definitely it will have a constant acceleration. Remember, for motion in one dimension, we derived the equations of motion where we said the first one would be given as v equal to u plus at. Then we said the second one, v squared, would be u squared plus 2a delta x. And then we said the last one will simply be delta x will be equal to ut plus half at squared. Now, when we're deriving this, we're assuming that we're moving horizontally on a straight line. But this time around, since free fall is a vertical motion, then we need to change all these words, especially our acceleration and then our delta x. It can no longer be delta x, but now it will be delta y. And since acceleration is constant, so we call it the acceleration due to gravity. So why that is called that, we're going to look at it when we talk about gravitational field later on during the course of our videos. Now, rewriting this to suit free fall, I can say v must be equal to u. Now, since in motion in one dimension, we say any motion we have going towards the right must be positive, anyone we have going towards the left must be negative, and anyone we have going upward must be positive, and anyone we have going downward must be negative. So the signs just account for it, the direction. These quantities are vector quantities. So we can say v must be equal to u minus gt, because the acceleration at this point, g is downward, even from 1 to 2. The force of gravity is downward. Definitely, the acceleration will be in the same direction with the force. At this level also, it is also downward. And sometimes we could see plus, but here our assumption, we want to make do with putting our minus or subtraction in our equation. So when we want to use the value of g, we make it positive instead. So instead of writing v equals to u plus gt, so we use v equals to u minus gt. Alright, for the second one, we say the same thing, v squared is equal to u squared minus 2g. This time around, instead of delta x, it becomes delta y. That is displacement vertically. And then finally, delta y is equal to ut minus half gt squared. And these are the equations that we want to use anytime we're giving questions on free fall. All right, so now I think it's time for us to start solving questions. All right, so for our first question, a palm fruit dropped to the ground from the top of a tree 4 to 5 meters tall how long does it take to reach the ground? The first thing we want to do underneath free fall is to try and make a sketch. So we make a sketch. So let's assume that this is a palm fruit. And then there's a fruit somewhere around here. The height of my palm fruit, so let's say, is 45 meters. Okay. Now, at this projectile, at the top of this place, since this is free fall, we're going to be solving or analyzing our questions in sections. That is, before we go further in this, let's just try and sketch. Imagine we're trying to throw a ball upward in this direction. Now my ball goes here, and when it gets to this final position, it drops down back to its exact starting point. So let's assume that this is the ground. All right. Now, what we can say or what we can deduce from here, analyzing this section, so let's call this point 1, let's call this point 2, let's call this point 3. And this type of free fall is what we refer to as a symmetrical free fall. When we say symmetrical, that is, you can see that its line of symmetry, look at the line of symmetry, divides this motion into two equal halves. We're basically saying the time it takes to move from point 1 to point 2 will be the same time it will take to move from point 2 or to drop from point 2 rather to point 3. So paraventure will ask for the time of this motion from 1 to 3. If we know from 1 to 2, so definitely we can know from 1 to 3 by just multiplying by 2. Another thing we can note from this point is at this highest point, if I were to be throwing the ball upward, this highest point, my velocity or my final velocity will be equal to 0. And my height will be maximum. Yeah, final velocity will be equal to 0. My height will be maximum. If my ball were to be dropping from this height, the ball initially is at rest, or someone was holding it like this tray, holding this ball. So we can see that the initial velocity here, v1, will be equal to 0, and then we calculate for other things. Now again at point 3, what we know is that my height is equal to 0, because point 3 is just when my object or my ball is about to touch the ground. Alright, so knowing all this, let's go back to solving our question. So we said the palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? So initially, we said our initial velocity will always be equal to 0 because the ball is dropping from rest. So if it's dropping from rest, definitely we can say initial velocity, which is u, must be equal to 0 meter per second. Acceleration, which is equal to g, will be equal to 9.8 meter per second squared. And then t is unknown. That's what we're looking for. Final velocity, also we don't know that. Vf, we don't know that. So what's formula can we use to get this? Okay, so we also have delta y. So delta y is minus 45 meters because we are coming down. This ball is coming downward, not shooting upward. Remember we said when we have a motion going upward, then definitely we can say it is it will have a positive value. When we have a motion coming downward, it will have a negative value. So delta y is minus 45. Sometimes the question asks for the height of the tree. The height of any object or the length of any object can never be negative. So we only take the absolute value of this. So just take note. So now that we have our parameters, so which equation or which of the equations of motion do we use? Do we use the first? I will say v is equal to u minus gt. No, we can't use that because we have two unknowns. Can we use v squared is equal to u squared plus or minus rather 2g delta y? Again, we can't use that because we have two. No, we have a single unknown, but then what we're looking for is not what the question is asking us for. What the question is asking us for is t, and then definitely we can come to use our delta y will be equal to ut minus half gt squared. So this way we only have one and then we're generating a quadratic equation. So delta y, we already said it is minus 45 equal to my u is 0 times t, we don't know, but everything here automatically returns 0, but let's just leave it like that for now. Then minus 1 over 2 g, we assume g to be 10 times t squared. So 2 here cancel out 10, that's 5. So we have minus 45 is equal to minus 5t squared. Now, what do? Divide both sides by minus 5, such a way that t squared will be minus 45 over minus 5. Minus cancel out minus 5 here, 1, 5 in 45, that's 9. So t squared will be equal to, or square root of t squared rather, will be equal to square root of 9. Square root cancel out squared, and then square root of 9 will give us plus or minus 3 seconds. Now our answer here will definitely be plus 3 seconds because time can't be negative. So this is how we can solve questions underneath freefall. First of all, you draw a sketch and then you answer in sections. Remember at point 1, when you are throwing the object, first to have an initial velocity or an initial throwing speed. Then at the maximum height, we say the final velocity is equal to 0. And remember the time taken, if it is symmetrical, to move from point 1 to point 2, will also be the time taken to move from point 2 to point 3. So let's take more questions concerning this. So for our second question, we're told that a bullet fired vertically upward from a gun held 2.0 meters above the ground reaches its maximum height in 4.0 seconds. Calculate its initial velocity. So what this means is simply, so firstly we want to sketch, like I said, so let's assume this was to be our gun. So you have to pardon my sketch, it's not accurate. And then the gun is held 2.0 meters high, 2.0 meters high from the ground there. And then my bullets, so let's assume this should be my bullets, okay, goes upward up onto this point, vertically upward, reaches this point in 4 seconds, 4.0 seconds. Okay, now calculate its initial velocity. So they want us to find u is equal to, what is this? Alright, so from what we said, at the maximum height here, final velocity will be equal to 0. Definitely, I know v is equal to 0, and then I know my g is 10 meter per seconds squared. So I can use my first equation of motion and simply say v squared, sorry about that, just v is equal to u minus g t. Remember what we're looking for, which is u. So 0 will be equal to u minus 10 times 4. Okay, u goes to the other side, we have minus u. So minus 10 times 4, that's minus 40. And then finally, divide both sides by negative 1. We know that u must be equal to 40 meter per second. And this makes sense because you can see that my bullet is going upward. So definitely to have a positive value. Alright, so this is all I have for you for this video. If you enjoy the content that has been released, do well to like, share, and also subscribe to your fellow colleagues. Thank you.